Hello, this is TJ, and today I'm back with a new Mastercam tip video. And what we are talking today? Okay, today I'm gonna show you how we can do a finish cut on of the edges in a solid without using a contour toolpath. So the goal of the tip is um, we can finish all of the edges in a solid like this automatically. That means we don't have to select the contour one by one, because uh, for a big part it maybe take a lot of time. Okay, so I have a sample part here. I can use this for demonstration. Okay, and let's take a look. This is a box. You can see a small box, and you can see the stock here. So for the demonstrating, I will make a rough toolpath. This is the roughing toolpath. Yeah, you can see this is the roughing toolpath. I will rough inside the park, and then follow with the waterline rest pass to clean the corner, to clean all of the corners. So, and a ram toolpath for roughing this small pocket. And after the roughing operation, I have the stock model like this. You can see this is the stock after the roughing operation. Yeah, I just want to machine inside of the part, so I skip the outside. Okay, now you can see this is how the stock look like after the roughing operations. In this operation, I leave 0.1 millimeter stock on the edges, on the wall and on the floor of the park. You can see in the parameter I leave 0.1 on wall and on floor. Also this waterline rest part, because I rough the part with a 10 millimeter tool, so I need, and there's some small corner here, so I want to do the rest roughing with a 6 millimeter tool. And this is the stock after 3 roughing operation. You can see we have not finished the floor and the wall of the park. You can see we still stock on the wall and stock on the floor, and choo 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 choo. After the roughing, I have a horizontal toolpath for finishing the floor on the park. Yes, like this. You can see the horizontal for finishing the floor, and I have another waterline toolpath for finishing the wall on the park. Yeah, horizontal finishing the floor, and waterline I can use for finishing the wall. And let's take a look on the stock after the finish operation. You can see it look pretty clean. You can see the wall is clean, also the floor is clean. But let's take a look on this. This is the waterline toolpath, the finished waterline. I leave 0 stock on wall and floor. And let's take a look on the cutting parameter. You can see the step down here. I use 2 millimeter step down. Yeah, that means yeah, you can see the step down here is quite small. It's 2 millimeter. But let's take a look on this edge. Yeah, here I'm gonna do a back. Yeah, I'm gonna do back plot. You can see on this depth, the tool is not clean. This floor here is not clean. Because we go down 2 millimeter per pass, and there is some floor that's not clean like this. You can see, because we go to 2 millimeter per depth, so there's some error here. It's not clean. You can see we still have the stock on the wall here. Also here, because the distance from the top to this floor is maybe less than 2 millimeters, so the tool will skip this surface and it will go down like this. I can show you. Okay, so you can see at the first depth it skipped this surface, so that's why we have not cleaned the wall here. You can see from here to here we still have stock on the wall, and also on this side you can see we still have stock on the wall like this. Yeah, this is not good. And also here on the bottom of the part we still have material left. So normally to clean this wall, if you want to clean this, you're gonna use the contour toolpath contour, and we can select the edges, the solid edges on the part, maybe like this. Ting 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 ting. In. Yes, one chain and go for another one, and yeah, and then we can pick one by one contour that we want to finish. But you see, if we work on a complicated part, a big part, so there will have a lot of chain we need to select. Okay, also this one, yeah, we have to select one by one, and it may take a lot of time. Ting. And also here like this. Choo. Okay, and we do like this for the rest edges, so it take a lot of time, especially for the big part, so that's not a good solution in some case. Okay, it should be 2D and 0 and no depth cut and incremental 0. Okay, yeah, it should be like this with the let in and let out. Okay, maybe like this. So this is the way we normally do, by using a 2D contour, and we have to pick the edges one by one, so it take a lot of time, and we still missing some chain here in the bottom. Okay, and also here we have to select all of them. So is there any other solution for this? Yep, maybe not. I just playing with some toolpath and I found one thing is pretty cool. Yep. Yes, you can try with the pencil toolpath. Yeah, you can try the pencil. Okay, let's try with a pencil. Select the park like this, and we select the boundary to limit the toolpath. Okay. Oh. I will try with the pencil toolpath first so you can see the difference. Okay. Dun, 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 and normally you do the pencil with the ball mill, but this time we can use with a flat tool so we can see what we have. I want to do one cut only, so we don't need to, yeah, so the number of the parts is set to 0. Okay, and okay, let's see what we have. Okay, it's running. Then do you see that? Oop. It's look. Yeah, it's look. You can see it clean the edges on the park, but it's look not good, right? You can see it's clean all of the edges like this, but there's some issue here. The path is not continuous like this. You can see we have some gap here. It's not a good tool path. Yeah, maybe we have to set this over thickness to maybe, because this is a flat tool, so if we want to clean this sharp corner, it should be set to maybe 0.1 or 0.2. So yeah, you can see that's allowed the flat tool can go into, because the pencil tool path is only work if the fillet on the part is smaller than the tool. So if we set it 0 here, it's maybe hard to calculate the tool path. But if we only input a very small value here, maybe 0.1, so now the radius, the corner radius of the tool may be considered 0.1, and it's now bigger than the fillet on the part, and now it can do the pencil. Yeah, like this. You can see the difference. We just need to input 0.1, and we can see we have a better tool path. Yep, like this. You can see it's clean the edges on the part. But there's one thing I don't like about the pencil tool path, because it only provides the vertical lead in and lead out. So when the tool plunge into the part like this, yeah, let's see where. Okay, let's take a look here. It's retract the tool here, and it will leave a mark here, because the pencil tool path it only support vertical entry and exit. It not support horizontal lead in and lead out. So when it do the entry and exit, it will leave a mark on the wall of the part like this. You can see when it retract or it plunge into the part, it will leave a vertical mark here, so it's still not good. So we need to find a similar toolpath. It's quite similar to the pencil, but it can provide us the horizontal lead in and lead out, so we can avoid the tool hit into the wall of the part. I do some play with the toolpath here, but I can't find anything good. But if you can accept the Mastercam multi-axis, you have another option that's called the triangular mesh. I think triangular mesh here. You click on this. And you go to the cut pattern. You can see on the pattern here we have a lot of cutting pattern, and there's one thing called pencil. Yeah, this is a triangular mesh, but with the pencil pattern. Okay, and it's quite similar to the 3D pencil. Yep, let's try it. Okay, you can select the pencil here. For you can see it has a lot of type of cut. It's like a 3D set of toolpath, so we can select the pencil here, and there will be a machining surfaces button here, and we click on this. Now we can select the box for machining surface. Okay, and we can input the offset value, so I don't want to leave any stock on the material, so I will leave it 0. And you can add a containment like in the 3D toolpath. Like this. Okay. You can set the cutting tolerance, maybe I don't know, I can use 2000. This means 2 micrometer. Okay, micrometer. And on the tool axis control, because we just do it on a 3 axis, so we're gonna select 3 axis. And if you want to check, you want to use the collision control, you can use it. But in this video, I just want to talk about the tip, how we can do the toolpath contour automatically. So we will skip the collision control here, and we also have some linking parameter here. Yeah, because this is the multi-axis toolpath, so you can have you can see we have the entry and exit option here in the linking parameter. And for the first entry, we can use the lead in, and we do the same for the lead out. And we can set the value of the lead in and lead out, for example 1 millimeter and 1 millimeter. So let's try, and we can select the same tool here. 6 millimeter. Okay, let's see what we have. Okay, you can see that this look pretty nice, right? You can see we have the lead out and lead in here. Yeah, in some position I can't see the lead in and lead out. Oh yeah, you can see. And also there is some edges that have not been cut yet, like this one and this one here, you can see it has not been cut, so we need to make some adjustment. I try to play some time with this to see how I can fix this. Sheep. We back to the linking parameter. For the gap size, I should select. You can select gap size by tool diameter or by fixed values. So maybe I input 2 here. And for small gap, we also use lead in and lead out, and for large gaps we also use lead in and lead out. Okay, let's try it again. We have to wait. Okay, you can see now we have the lead in and lead out here and here also. So because we're using the lead in and lead out, so the tool is not hit directly to the part. You can see the tool entry here, entry at this position, and it goes slowly to the part like this. Yeah, it's automatically, so we don't have to pick the contour. You can see it clean all of the edges. Yeah, maybe I'm not right, but there's still some edge that not have been clean, like this one, and this one. I really don't know why it cannot clean all of the material. But you can see in the 3D pencil toolpath we have a parameter that's called over thickness, but we cannot find it on the triangular mesh. So we have to do is manually, instead of input the over thickness value, we will modify the tool. Okay, you can see this is a 6mm with 0 corner radius. So I'm gonna make another tool the same with this one. Yes, and edit this tool, maybe number 2, and instead of making it the sharp corner, I'm gonna select corner radius. Yeah, and now I will input a very small value, maybe 0.2mm. Okay, click finish. Now you can see I have another tool, 6mm, but have a 0.2 corner radius. So now you can see the corner radius of the tool is now greater than the corner radius of the sharp edges here. This is 0 corner radius and the tool is 0.2, so maybe it can help creating the pencil toolpath, and it will not miss some edges. So okay, now I try to copy another toolpath. You can see this is the old one with the number 1 flat tool, and the second I'm gonna select the new tool we just created. Okay. I picked the tool number 2 with 0.2 corner radius, and let's see what happened. Yeah. Now it's look more crazy, but you can see here this edge now is cut, also this one and this one, so the tool pattern now is not it does not miss anything. So all of the edges is clean now, but there's some crazy thing here. You can see, oh, it do some cutting on the chamfer here. We have another way to fix this issue. We just go back to the cutting parameter, and we have something called the angle range. So now we can limit the angle, so the tool will not cut into the area we don't want. I activate this one, and you can see it will be here, angle range, and now I can set the angle. Maybe we just want to machine from 80 to 90 degrees, so only steep and vertical wall will be machined. Yeah, you can see here, machine between slope, I don't know how to spell it, slope or slope angle. So we just want to machine from 80 to 90 degrees, so it can skip the 40 degree chamfer here. Let's try it. Ping. It takes some time to calculating. Okay. Yeah, you can see that. It's look better now. You can see it's machine all of the edges on the part like this, but there's some things still we need to take a look here. Yeah, the tool path is not continuous, so we back to the linking parameter. Linking. So we have a small gap here. If the gap is too small, we can make it follow surface. You can see from here to here we have a small gap, and if you want the tool path is continuous, so we just select follow surface. And now take a look again. Let's see. You can see we have two different tools with two different results. Now it's better. You can see after we set the small gap option, we select follow surface. So when the tool go here, and if we have a small gap here, it will follow the surface, and we will follow the contour here, so the tool will not retract. Yeah, like this. You can see now we can cut all of the edges automatically. This one is 6mm, no corner radius. It's a sharp edge, sharp corner tool, and this one is a quite similar tool, but only have 0.2 corner radius, and the small difference make the difference. Yeah, you can see because we have 0.2 radius here, the corner of the tool is now bigger than the corner of the edge, which is 0, so the pencil tool path can be generated. I can try to set the radius of the tool to 0.1 maybe, yeah. And you can see we have some problem. If we set it too small, it can be a problem. Let's take a look. So I don't know if it can call a tip, because sometimes it work and sometimes it not work. It depends on your part, the quality of the surface. Yeah, so maybe you can try, and if you're lucky it's work like this. It's very nice, right? Yeah, you can see when I set the corner radius of the tool is 0.1, and this edge is not cut. Also this one, the toolpath is skip this position and this position. So, and also the small edges here and here, yeah, it's really crazy. So if you set this corner radius too small, the toolpath may skip some error, so it's better make it not too small. Yeah, there's one thing, remember, this is only the tool you define on Mastercam. In reality, you can use a flat enemy with no corner radius. We just use this corner radius for toolpath calculating. When you machine the part on the machine, you can use a totally flat, totally sharp corner. No need this radius. Yeah, I just want to use this corner radius for calculating to make the trick. Okay. So when I set it back to 0.2, you can see the result is better, is much better. Yeah. You can see. Yep. There's one thing I don't like about this is we cannot control the position of the lead in and lead out. You can see when it's something here, you can see the tool go it start to cut at the corner, so in some cases it's not so good, but overall it's look pretty nice. With the toolpath you can finish on the you can clean the edges automatically. But there's one thing you need to remember, this is a 5-axis toolpath, so when you pause this, you may not have the arc like this. All of the toolpath is linear, is G1. You cannot have any G2 or G3. Yeah, I think so. I can try to pause it so you can see. This is a 5-axis toolpath. Take a look. You can see that this is the program after we paused it. This is, yeah, all of them are the linear motion. It's not the G2 and G3. It's only G1, only linear motion. Yep. Because this is a 5-axis toolpath. So I think I don't know if this tip can help you in some case, but it's quite interesting to me. Okay. And with this toolpath we can also do the finish automatically. And the second thing, we have the lead in and lead out motion, like a 2D contour. It's very nice. It's good when you make the tool start from away from the wall, not straying into the wall. if you use a 3D pencil toolpath like this, like the one I used before, you can see the tool is during the lead in and lead out motion, the tool will leave a mark on the wall like this. So it's not good. I think it's not good at this one. Okay, we can do a simulation. Yeah, this is the stock and this is the park when it's roughing. And rest toolpath, this is the waterline rest toolpath. And this is the horizontal cleansing the floor. You can see this, the floor has been cleaned. This clean the floor, and now the waterline finish the wall of the park. Yeah, this is the waterline cleaning the wall, and you can see we still have stock here and here. Because of the depth cut, it cannot clean the corner. You can see we still have stock here on the wall. So now we go to the triangular mesh. I don't know how to call it. Okay, and it can clean the park like this. Choo, 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 choo. Oh, I mean, I make a mistake. I should not select this contour. Yep. Bing. Because the contour it doesn't have the collision checking, so it's hit to the corner here. I don't want to use the 2D contour because this video focus on the triangle mesh toolpath to do the finish automatically. Yeah, I mean automatically, so you don't have to select the contour one by one. Yeah, you can see this is the triangular toolpath. It's a 5 axis, so it is a little bit slow. All of this motion is G1 linear motion. Yeah, you can see it clean the corner. It's clean all of the corner. Chính em nghĩ ra mà, chính em nghĩ ra mà. Yes, now the park is clean. We can turn off the color, so you can see we have a smooth park here. So it's recommend you turn off the collision control to avoid when it's do the cut here it hit into the park, or you can reduce the lead in and lead out distance. We have a small collision here because I turn it off the collision control in the toolpath. Okay, so this is the topic today. I hope this can help you maybe in some cases. Okay, thank you and goodbye for now.